Hello, students. I'm so excited to move on to part 3 today. Today, we're going to bring back factoring. Remember, factoring and even expanding are two skills that they won't quit on us. We love seeing those skills show up and they just keep coming back to us. So again, our ultimate objective is I can simplify to show the left-hand side is the same as the right-hand side. And we're going to add in a new objective today, which is I can use factoring when proving an identity. Let's go ahead and take a look. So I'm going to begin by reviewing factoring, and I'm reviewing factoring in a different way today. When factoring, it's really important to make sure that either you have a common pattern or all the terms in your problem are all in the same trig function. So right now, we can see that cosine squared and sine are not the same. But I do know that sine squared plus cosine squared is equal to 1. So I can replace cosine squared with its equivalent if I just do a little bit of rearranging. So I went ahead and I rearranged, and I'm going to replace just this term right here with 1 minus sine squared. So we have sine x minus 1 minus sine squared of x. Notice I put it in parentheses because that negative is going to affect it. Now I'm going to distribute that negative in and do a little rewriting. So we have sine x minus 1 plus sine squared of x minus 1. And finally, before I can even factor, I'm going to rewrite it now in descending order. That means with the squared term first, the regular sign second, and our constant at the end. Now that it's in a format that I can actually work with, I'm going to go ahead and start my factoring. When factoring, we ask our magic question. So what adds to equal the coefficient in front of the middle, which in this case is an invisible 1, and what multiplies to the product of the first and the last term, which in this case is a negative 2. Very quickly, you're going to come up with the only two factors that are possible are 2 and 1. And if we have a positive 2 and a negative 1, it allows for those statements to be true. Next, I'm going to create my factor box or sneaky square, whatever you call it. And I'm going to place the first term in the first box, the last term in the bottom right. And then I'm going to put 2 sine x and negative 1 sine x in the diagonal boxes that were not filled in. Factoring out what's in common, sine x times sine x is sine squared of x. And multiplying by negative 1 gives me negative sine x, and multiplying by 2 gives me 2 sine x. So we now factored this to sine x minus 1 times sine x plus 2. So that's just a review of factoring. What you're going to see is this process is now going to be built into some of our proofs, and we're going to have to start to recognize, oh, if I factor this, I can reduce. It's very similar to that algebraic proof that we saw at the beginning of our part 1 video. All right, let's get into just reviewing our tips and tricks. I like to do this before each lesson, and then we'll get into our 2 examples for the day. So again, our tips and tricks list includes always begin with the more complicated expression. Typically, this is going to be the problems that have adding in them, but not always. Again, you just really want to look at the problem, and maybe you see something different than I do, and that's okay. There are many approaches to doing this. Your second tip is if you are unsure of where to go, you can try changing everything into terms of sine and cosine. Your third tip is combining fractions by getting a common denominator first. Again, that only applies when you're adding or subtracting fractions. And your fourth, which is our new add-on of the day, is factor so you can reduce. The most common factoring that shows up in these problems is that difference of 2 squares. We've seen this happen in other cases. And so what that is that's that a squared minus b squared, factoring to the a plus b times a minus b. With our trig functions, that would be like 1 minus cosine squared. We can factor that to 1 minus cosine times 1 plus cosine. So again, just trying to give you some frame slash mindset to help you with that. All right, let's go ahead and move into a problem. So in example 6, we see that we are trying to prove that the left-hand side equals the right-hand side. And so I always begin, which side actually looks more complicated? Is it the left-hand side or is it the right-hand side? Now, when looking at that complicated concept, you want to say, which side can I actually do something with? Well, in this case, the left-hand side is more complicated. And so because that's the more complicated side, we're going to begin there. Now take a second before you write anything. Don't dive in right away. Take a second and look at the problem. See if you can make any connections to what you're seeing. Again, there are many approaches to what people might do, but I just want you to keep a nice open mind. When I look at this problem, I see cosine squared and I go cosine squared on the top and sine on the bottom. Really, the only thing I know for sure is I have a Pythagorean identity. Cosine squared plus sine squared equals 1. Now, if I solved this for cosine squared, I would have cosine squared of x equals 1 minus sine squared of x. I like that because now I don't have any cosines, and because I want to end up with a sine, it makes sense to me to get rid of the cosine. So I'm going to make that decision. I'm going to put that into my problem. So I have 1 over 1 minus sine squared of x, all divided by 1 plus sine of x. Now, as I look at this, I go, okay, I can't cancel this. Some people are very tempted to do some dividing here and say, well, 1 divided by 1 is 1, and this divides out to being a negative sine of x. Not really. You can't do that, so don't do that. I know you're tempted, but don't do it. Run away, run the opposite direction. But what I do see is that this part is the difference of 2 squares, and so I can factor that to 1 minus sine x times 1 plus sine x. So again, I'm using this reasoning column to kind of be like my scratch work. So I have 1 minus, I'm going to rewrite that numerator as 1 minus sine of x times 1 plus sine of x. And on the bottom, I have 1 plus sine of x. And that's really great because now I got rid of my fraction because 1 plus sine of x divided by 1 plus sine of x is 1. So I'm now left with 1 minus 1 plus sine x. Be careful, that negative sign again is showing up where if we don't distribute it into both terms, we're going to break some rules and our proof is not going to end up working out. So in this case, we did a simplify and distribute. And I'm writing down that distribute because, again, we've seen it show up every single day because it shows up so often in these proofs. Now, the last and final step, positive 1 and negative 1 is 0, so I get sine x equals sine x. And just like that, we have finished the proof. So one of the biggest questions I get from students is, how do you know when you're done? Well, when proving something, you're done when you make both sides equal to each other. Oftentimes, students want to circle that final answer, that final statement. But technically, it's all the work that happened in between that allows for this to be the case. So I would need to see all that work if you were doing it on paper. All right, let's go ahead. I have one more example for us today. Again, keeping it simple today. It's been a lot of work. So in this example, we are going to show the left-hand side equals the right-hand side. And I'm just going to go ahead and write right above that left-hand side, right-hand side. And I'm going to give you a second just to process that and take a look and say, okay, what side would we want to start on? Now, for some of you, you might say, Miss Vernon, I have no clue which side to start on. This is complicated and I just don't get it. Well, there are times when we have to work on both sides. So just know that sometimes you have to work both sides. But for me, in this case, I'm going to start on the left-hand side, knowing that I might have to do stuff on the right-hand side, but I'm going to start here. And the reason I'm going to start there is because I have that cotangent squared. I know that cotangent squared plus 1 equals cosecant squared. And if I can get it in terms of cosecant, I might be able to do some factoring. So I see cotangent squared is equal to cosecant squared of x plus 1. Oops, sorry, minus 1. I apologize. Let me fix that real quick. All right, so cosecant squared of x minus 1. And so I'm going to replace that on that left-hand side. So we have cosecant squared of x minus 1 over 1 plus cosecant of x. And again, just like we saw with the previous problem, this is that difference of two squares. So I can factor this to cosecant of x minus 1 times cosecant of x plus 1. And you might say, okay, Vernon, I see that, but what's the benefit? Well, again, it just allows us to do a little more simplifying. So I'm going to write that in. And just like that, there's some simplifying that can take place. Even though they're written in the reverse order, they still are equivalent. Think about it. Is 1 plus 2 the same thing as 2 plus 1? Yeah. So the order in which we add doesn't matter, which now has allowed us to simplify that left-hand side to a fairly nice answer. All right, well, now we kind of stalemated. We're kind of stuck because I don't see how I'm going to make that turn into this. So guess what? We're going to switch and now we're going to work the other side because there are times when we have to work both sides of the problem. So I'm going to make a note that says now, and maybe I'll put the word stuck. We got stuck. What that means is now we work the right-hand side. But notice that I worked the left-hand side for as long as I could before switching over. All right, so we're going to work the right-hand side. We've got this going on. Where do we begin? Well, I would begin by distributing. So distributing, now again, notice I'm not going to touch that left-hand side. I'm only working the right-hand side now. I would get cotangent of x times secant of x, distributing to the first term, minus cotangent of x times tangent of x. Now, some of you might go, oh, I see something, Ms. Vernon. Remember, you told us that cotangent of x is equal to 1 over tangent of x, which means, technically speaking, these two are going to multiply to give us 1. Awesome. That's a great idea. But I'm also going to go ahead and switch this over because I'm not seeing secant come out of that. So I'm going to go ahead and rewrite this in terms of sine and cosine just because I need that visual. I just need to be able to see that. And when I do that little bit of writing, I do see the cosines cancel out. So I'm left with 1 over sine x. And here I see the tangents cancel out. So I'm left with 1. And we're very, very close because 1 over sine x is equal to cosecant of x. All right, so all the way down here at the bottom, we can now see I did have to work both sides, but eventually I did get to the answer that was making them both be equivalent. So sometimes we write both sides in a more complicated way, and it requires you to really be diligent about simplifying one side as far as you can, and then moving over to the other side. Now, are there times where you might have to jump back and forth? Absolutely. But try really hard to focus on one side at a time so that you don't miss something or you don't do too much and end up having to backtrack. All right, I hope proofs are starting to get a little bit easier to recognize. It's not uncommon for students to say, I get it when you teach it, but I don't get it by myself. So stick with it, keep trying, but set a timer. Don't spend hours looking at proofs. Give it a little bit of time, take a break, and come back later. Have a great day.